Hi, everyone. Thank you for coming to this talk today. I'm Prattyush, and I work at IBM Research. I'm a research software engineer. I've been working with IBM for about 6 years now. Today, I want to be talking to you about what it takes to go production with your AI agents and the transition we're seeing from the reliance and the use of large language models to small language models. Before I get into some of the specifics, a little bit about me and what enables me to talk about this topic today. So I've built production-ready cloud applications, being in IBM software for a few years. About 3 years ago, I moved into research, looking at LLMs and agentic AI applications. And about a year ago, I joined the IBM Granite team, which is the family of generative AI models from IBM Research. And in that role, I'm working in a semi-developer relations, client engineering role, where we work a lot with clients and product teams to help build generative AI applications and get them to production scale so that they can ship them to their clients and see that utility scale with generative AI in the real world. So through that engagement and through those conversations with clients and product teams, there's a lot of learnings that our team has made and some anti-patterns we commonly come across. We've tried to socialize and externalize a lot of our learnings, develop opinions and recipes, cookbooks to help anyone else wanting to undertake that same journey of, building AI agents and generative AI applications ready for production. So this is the repository that we've been externalizing that content on, and this is the repository and specific notebooks that I'll be referencing throughout this talk. If anything stands out to you, as in, oh, that's new and I haven't thought about that, there'll be a link at the bottom of that slide referencing one of these notebooks that you can access, play around with, and maybe talk to me over the next couple of days if you have any more questions on as well. So let's get started. So what's the production agent problem? How do you scale up these demos that look cool to robust and operationally viable solutions? So what happens often is my team will interact with a new client or a product, and it typically goes like this. The product management or the developers themselves have identified a small set of use cases that they want to build some generative AI application for. They have written some code to do that, to meet those use cases. They do some manual validation, and once those manual validations, the ad hoc testing passes, they're ready to ask the question of, hey, can we go and package this and ship this to our clients and users? In some cases, they do enable the clients and give users access, and the users provide feedback. This is what that looks like. This is some of the things that we've seen in real time feedback from the clients and these engagements that we work with. Things are working great. It does exactly what I want. It saves me 50% of my manual effort. Sometimes things get a little bit worse. Agent is great, but it still gets some things wrong. It's good, but I don't trust it on my production environment. Sometimes it gets a little bit more gray. Agent seems to get slow at different times of the day. Agent fails if I open too many chats at the same time. And sometimes, the clients and the users are very succinct in their feedback. Agent just doesn't work. Agent costs too much. So these are some things that, we've personally experienced and heard in the work that my team does engaging with these teams to roll out to production. One of the feedbacks that we haven't seen, but maybe you guys have seen is, agents just deleted my production database. So no promises, but hopefully as part of this talk, you'll get some pointers and some checkpoints as to how to avoid this sort of situation. We're going to split the talk into two sections, two parts. So the first is going to be model agnostic, size of model agnostic. How do you go about architecting and designing a system that's robust and ready to even go through the considerations of production with? And then we'll talk about what's the point of small language models? What are they? If you want to migrate, what's the value prop and how do you do that migration? So let's dive into part one. And the first checkpoint we always tell teams is define your requirements. Start with well-defined use cases and your deployment needs. So here are the questions and steps that I'd recommend you guys go through in terms of a brainstorming exercise. So the first thing to ask yourself is, what's the domain? Are you looking at agents that access services in the cloud and read data from them or enact some updates to them? If so, maybe you're looking for the tool calling type of approach of agents. Do you have knowledge base Q&A answering type of use cases? So maybe you want to look at the RAG architectures. Do you actually have coding use cases? Do you want to build coding agents? Is your domain actually a little bit more gray and overlaps across multiple of those? Maybe you want to look at skills-based and deep research-based agents. You want to define whether your agents are going to be product-specific or task-specific, and where are those domains and boundaries that you want to gate your agent functionality around before you even start putting paper to pen or Claude Code to VS Code. Next is define your user experience. So are you building something that you expect users to be interacting through a chat interface, or is it going to be a CLI-based sort of interaction? Do you expect some integrations into an IDE maybe if you're wanting to build a coding agent? You want to also think about the use cases that you're trying to tackle with these. Are they multimodal? Because that might restrict the models that you're able to access and connect up to your agents. Also, streaming interactions, what does that user experience look like? Uniquely for production, you also want to have a consideration for your agent management. So what does agent billing look like? What are your requirements there? What is the data management? What are the client requirements for the boundaries within you're going to be managing and working with their data and their data sovereignty? How do you work within those restrictions and still build a pipeline such that your agent can iteratively improve on the feedback that you're getting from clients, even if some of the feedback and some of the data might be obfuscated in terms of the agreements you have with those clients? One thing we uniquely see within IBM often is define your deployment. Are you looking at on-prem clients, or are you looking for clients who are just wanting to interact with your agent through some cloud-hosted, software as a service, agent as a service approach? In the on-prem world, if you're thinking about, deploying something on your client-specific hardware as an agent, you also need to package an inferencing stack to go along with that. And if so, do they have specific hardware requirements in terms of the number of GPUs that they have on their on-prem infrastructure, which might limit the size and scale of the models and the agents that you're able to build? One thing that not just agent developers fall victim to, but also normal software engineering projects fall victim to, is not thinking about non-functional requirements early enough. So thinking about things like concurrency and multi-tenancy. How does your agent scale as your number of users scale? How does your databases, how does your MCP servers scale as more and more calls are going out to them? Can you actually handle 50,000 concurrent users? Do you even want to handle that? What are your response times that you're looking to get? And again, what is the per agent invocation cost of inference? Those kinds of considerations you want to ask yourself, and you don't need the answers before you don't need the answers fully before you start coding up, but having these as a point of reference and being aware of them is going to help the transition easier when you want to productionize. And for each of these 5 points that we mentioned, define your use cases, define your test cases, and build in these suites of tests so that as you upskill your agent, as your agent complexity increases, you're able to get checkpoints on each of these metrics, each of these requirements, and see how you're progressing. Okay, you've defined your requirements. How do you want to build your agent? So I'm a mathematician. We like to be very lazy, and I take that into my engineering role very intentionally as well. So I would say complexity isn't necessarily better. Design the simplest system you can, and then implement more advanced architectures based on your use cases and your testing performance. So I'm going to give a quick reference guide to the agent architectures and the plus points, and then we'll talk about how do you go between them maybe. So the first thing we always suggest is the basic geometry. Start with that. Build a function calling agent, which basically associates a large language model or a language model with some functions definitions. So what is that function that the model can choose from? What does it do? What is its input parameters? What are its output parameters? So a function calling agent is just going to take those function definitions, throw them to a model along with the user query, and come back with a response of, based on this query, I think you should use this function with these parameters. And then your program around that model is going to go and actually execute that tool and get the response. So just as a quick reference of what those cookbooks look like and what a function calling agent looks like, it's 4 lines. Oops, 1 second. Okay, a function calling agent can be defined in 4 lines. Those are right there at the moment. So start with that. What we do in these cookbooks is that we show you the easy way, but we also try to demystify what goes under the covers. So if you follow this cookbook, for example, and give it a go, you'll see how to build a function calling agent from scratch, rather than also, just using that utility outside of the box from LangChain. So that should help position you and demystify a little bit of the world of what's happening under the covers with these agents and their models as well. Okay, so you built a function calling agent. What other architectures exist? So there are reasoning agents. Maybe you've heard of React agents, which are reasoning and action agents. And these work better if you want to understand why the model is choosing what tool it's choosing and do some validation and augmentation of that reasoning and tool selection before you actually go invoke it. One thing I want to call out on a reasoning agent is make sure that in your prompts, you're asking the model to give you the reason first before it gives you the tool. Because these are autoregressive models. If you've asked it to give it the tool first and then the reasoning, the tool selection is going to influence the reasoning it gives you rather than the other way around. You kind of want it to think and define its reasoning before it selects the tool call that you should make. We also see planning agents. So these are agents which will define completely fully formulated plans of do this, do this, do this, and get those plans out before they actually execute. And we see this very helpful in architectures where you want to have some human in the loop validation. So if you are dealing with production systems, maybe you want to validate the tool calls and the plan that the agent has generated before you actually press play and it goes and does those things. There's routing agents. So this is the most common and most effective, multi-agent architecture that you might be familiar with. It's grouping your tool sets into domains and building simple function calling agents for each of those, and then orchestrating between those multiple function calling agents with some orchestrator agent at the top, which selects one of your sub-agents. Similarly to how a function calling agent is going to select a tool, your orchestrator agent is going to do the same sort of step to select the sub-agent before the sub-agent selects the tool. Suppose you have a use case or you have hundreds of tools, and maybe they don't fit into well-defined subdomains to go the routing architecture. One other architecture we recommend and roll out to production with is called tool RAG. So instead of going to the model with your query and your 200 tools, what you'll do is you'll sort of perform a RAG on the whole set of tool set, on the whole tool set, and pre-filter those before you show them to the model. You'll only show the subset of the tools that are relevant for the query to the model to select from, and that should help with accuracy and tool selection, things like that. One cookbook that we have in the works right now is skill-based agents. So these are agents which might interact with your file system locally. And these are a little bit more dynamic because they can write code, they can execute code, but you have to be a little bit more careful with these because if you want to write and execute code, considerations of sandboxing and protecting your local data file system considerations come into the mix as well. So how do you go between these agents? How do you go decide what architecture is the best? We advocate for test-driven development. So how many people in the room have heard of test-driven development before, by the way? Great. So why not bring that to the agent world? Where you write a failing test or you define a use case and then you write the code to meet that use case. It's kind of exactly the same approach that we document with clients and product teams is define your use case, build something simple, see if it works, extend your use cases, go again. And so what are the things you want to be thinking about and testing when you're doing TDD? So the first is functional accuracy. So programmatic validation on, hey, is my agent calling the right tool in the right way, in the right step? And then is it doing the right next thing after? All of that can be programmatic validation of what tool did it select, what parameters did it use, what next tool did it select, for example. Functional accuracy also goes into RAG. Atul, you asked the question in the last one of, what about RAG evaluations? So some of the blogs at the bottom there will will help identify some techniques for that as well. You want to look at answer quality. So what's the final response that you're getting back from the agent after it's done its processing, and how effective is that answer? So you want to be looking at maybe relevance. You want to be looking at recall of the information that the agent has collected in its intermediate steps, and is that represented well in the final response? So you might want to look at LLM as a judge technique for that. That's pretty effective. But one thing we would recommend there as well is make sure for your use cases you're defining some stubs or some example golden responses that your judge can use as grounding to measure the actual agent response from. Don't just let it go and judge the agent response without any other context of what you're looking for. We want to be looking at multi-turn accuracy. So I'm pretty excited for the next talk in the same room about how do you go implement that. So this is really about, how does your agent degrade over time as context increases? How does tool calling capabilities maybe decreases as your context increases, that sort of thing. Non-functional requirements, as we've said, so let's talk about goal completion. Is your agent doing what you wanted it to do? But there's also on the flip side, the resolution efficiency. So how many tokens did it take? How many LLM invocations did it take to do what you wanted? How many turns between you, the user, and the LLM or the agent did it take to actually achieve that use case that you were looking for? Build in these concurrency tests and these latency tests, these time to response tests as well. We also do analysis on the verbosity of an agent, because if you think about it, verbosity impacts latency, but it also impacts the cost of an agent. So clients and users are being more and more aware of skyrocketing costs, just with a little bit of being a little bit loose with the token usage that these agents or these models use at the moment. So RAG accuracy, examine how effective your chunking algorithms are being and how effective your retrieval algorithm is being. If you ask a vague question, is it actually going to the right place in the vector database and retrieving the right and relevant chunks to actually formulate answers from? So you can dive into the maths of that as much as you want. And we can talk about that after, but anyways, on the remark of, when you're productionizing, the cost considerations are something that we're seeing come into the mix very fast for clients. And to the point that, some agents are being developed in a specialized way to even optimize not only on their token input counts and the token output counts, but also on the KV cache refreshes that your prompts are invoking into the model runtime, for example. Okay, so now you've built your agent, you've defined your agent, you've defined your requirements, maybe you've experimented with a few architectures gated with well-defined test cases that help you identify how your agent is doing. One thing that I think I skipped over was that little star remark. If you have that infrastructure and that evaluation framework, you can also use that to identify which model actually should be used for your agent. And maybe through that evaluation, you're able to find out that you can work with a smaller, cheaper model to achieve the use cases that you wanted. So evaluation framework, automated on all of these metrics, must to go to production. How do you now, you built an agent, you're happy with it, maybe you want to think about going outside with it. You need to be observing your agents so that you can ensure your agents are operating as you want, but capturing when they don't. So one thing that we work with these agent development teams with to instrument is observability platforms. One that we found really to be useful and easy to integrate into applications is LangFuse. So at the bottom there, you've got the notebook that you guys can have a deep dive about how do you provision LangFuse, how do you set it up locally, how do you read traces, how do you navigate that, and you can actually use LangFuse to do some of your agent evaluation as well. So thinking about using one of these platforms might even inform your evaluation frameworks and delegate some of that development effort. So we've been using LangFuse to parallelize this debugging effort. If something has gone wrong, we can send a link to all of our engineers and say, hey, that trace went wrong. Now we're speaking the same language. We're able to reproduce it locally and then see, hey, are all our engineers seeing this, or was this actually a runtime something of intermittent failover that maybe isn't reproducible all that often. Because LangFuse is also specific tracing for LLMs and agents, it helps you identify problems to specific nodes within your agent architecture. And that localization is pretty helpful. So if you see there at the bottom, there's a very simple graph, but this graph can visualize your whole agent architecture, whether there's a node for RAG, whether there's a node for tool calling, a node for validation, a node for response formulation. Through LangFuse, you're able to identify which of those nodes is actually the root cause problem, and then you can localize your engineering efforts to enhance that a little bit. We also use LangFuse for our token and latency analysis. So at the top, you can't see it, but it's capturing every invocation of this model, how many input tokens went in, how many output tokens came out, and what was the latency. So you're able to, and we actually do this, we're using it to model how latencies change, how tokens change with concurrent users, etc. as well. It's very lightweight and easy to get up and go with, so I would definitely recommend that tracing notebook. It's one of my favorite on that repo, and we've found this actually to be a key enabler in driving developer confidence to productionize their agents and deliver the enhancements as well. Some things that I'm just going to quickly run over is extension points that you want to think about. So AI gateways to rate limit, to monetize, and to easily swap in, swap out models for your agents without having to go and update your agent code maybe, is something we're seeing a lot of production-ready agents undertake as well. And we're also seeing actually AI gateways as a means of guardrailing, as a means of making sure there has not been any prompt injections that were unintended, and doing prompt injections from the agent developer side to localize different domains of information that you want to release to the agent, to the users or not. For example, maybe you just want to enable the users to see their own chat histories, and you want to obfuscate the unique prompts that your agent has been designed to use, because that might be a differentiator for your agent. So we're seeing AI gateways as the way of, okay, the user is sending this data, the AI gateway is now going to augment that with the agent-specific prompts that are proprietary and designed by us, and then we're actually going to hit the model and get that result back. When we get that result back, we're going to obfuscate some of the data that maybe we don't want to give back to the user, and do some of that. So AI gateways, collecting data, using data, you guys want to be thinking about this a little bit more as well. So, can you utilize this collected data to identify, triage agent failure patterns, and then can you extend your regression tests that you've built to those test cases that you might have found that the agent wasn't doing well on, so that you can validate that in the future, you're going to be doing better on those going forward as well. We also see this sort of golden memory sort of approach, where if you have this feedback loop available in your agents, and a user has validated that, hey, look, the agent did well on that one, you can sort of build a golden memory RAG database that documents when the user asked this, the agent did this, and it was the right thing to do. So that when future queries that are aligned to that similar sort of validated query previously, we can retrieve that previous agent processing and reasoning and use that as additional context to go to the agent with to help augment and give us a better chance of doing the right thing for that query. Okay, you built your agents, you're observing your agents, they're well tested, now you want to actually go and roll them out. So let's talk about agent-specific CI/CD considerations and deployment considerations that are unique to agents. So anyone who's ever done CI/CD with Travis, Jenkins, or GitHub Actions, whatever, source management is one thing. It's how do you version your code, how do you validate what commit of code was running on the user's side or the client side to help debug and identify things and deliver fixes. Well, in agents, we also recommend for you guys to think about your model usage and how do you manage a version that. We recommend treating prompts and model usage as config rather than as code. So externalize your model prompts, externalize your model parameters, externalize your model names from your agent code bases and use them as runtime configs. so that you can version your agent logic as one piece, and you can version your model logic, or sorry, your model usage as another piece. What that means is as new models come into the open source maybe, or Claude releases a newer version, you can just drop in that new model config without having to update your agent code and get the benefits for free basically. Packaging your agents. So classical software, we're familiar with packaging it as containers, as binaries. You can also do that for agents, but some unique considerations are, do you want to package your agent and expose it as a web server? Do you want to expose it as an MCP server, an A2A server? And what those latter two categories enable is, if you've already built your agent as an MCP server, it can then be viewed as a tool for another overarching agent. And so therefore, you're building extensionability by design. And you're having to take on less development cost in the future to add in more functionality in the future. Also, if you want to be building, coding agents or dynamic agents, deep research agents that access local file systems, maybe you want to build your agents as binaries so that you can obfuscate and make it harder for your clients and users to see the agent architectures and the prompts. Deploying agents. So there was a question in the last call about, agent core. I think you got to have an answer to, how does your agent scale as it sees usage? Hopefully, whatever you build is going to only ramp up in its usage and its engagement from different users. So think about your deployments for Kubernetes and OpenShift, and if your agents are running locally, what types of models do you need to be running locally, and inferencing stacks, and how memory grows as well as your context grows or your number of chats grows. So this was a super fast whistle-stop tour of agent architectures in general. We're going to move over to part 2 now, small language models and what this new world is. So hopefully what you're going to get as part of this is, how can going small help mitigate some of those concerns that we spoke about of skyrocketing costs, of parallel users, etc. And then how do you go small? So before I go into that topic, anyone here have a reference of what is a small language model? Anyone want to shout that out? Yes, go ahead. Okay. Any others? Okay. Anyone else? Yes. Sorry, say that. Sorry, I'm not able to hear. Local deployment? Yep. So I think there's a lot of different definitions for small language models, and there's not one right one. Even when you're talking about locally runnable models, it depends on the size of your Mac. It depends on the size of your laptop. Do you have 64 gigs of RAM, and then all of a sudden the model you can run is way bigger than the one you can run if you have 4 gigs of RAM. So what we sort of standardize upon as a small language model is three answers maybe. We treat maybe the 30 billion parameter model as the upper bound of being called a smaller model. We look at models that can run and fit on one node, maybe one GPU, one laptop. That's another definition that we treat as small language models. So I want to go through 2 quick case studies of how we're actually seeing small language models transition and be the answer to production applications. So DB2 is a database offering from IBM. And what they had was they had these clients where the clients wanted on-prem deployments of their agents, and they had air-gapped environments. So that meant that the DB2 team needed to build an architecture where they could run open models locally and have a scalable inference stack locally as well. The clients had, hardware constraints. They had a few enterprise-grade GPUs, and they wanted concurrent users. So that meant to actually get the reliability, the resilience, and the scalability, your models had to be sufficiently small so that, whatever memory you have, you can use it in terms of scaling up rather than just using it for one model deployment or one agent deployment. Okay, they had, real-time inference, so they needed fast inference as well. And they had all of these different domains of use cases. So they did exactly what we spoke about. They built test cases for the non-functional, the agent requirements, and they automated that to the point that they're running 200,000 evaluations automatically, and they're running 35,000 manual evaluations as well, and they've built that observability stack for it all to be traceable. And the outcome of that was they were able to use the IBM Granite 4 hybrid small model, which is a mixture of attention model, mixture of experts model, which was smaller, faster, cheaper, and led to a 50% footprint reduction to the other leading model that they were initially looking to ship with. And if you're talking about 50% hardware reduction, footprint reduction, you can view that differently as, now you all of a sudden you might be able to service 2 users on the same footprint rather than just 1. What about costs? So DB2 was a proof point of scale. So Safer Materials Advisor is a use case. Basically, enterprises have large supply chains. They have a lot of products that they consume and that they build, and they have to release basically ingredient sheets to the governments and to local authorities. And so there's a lot of analysis work to identify if anything in those ingredient sheets is negatively impactful for the environment. So Safer Materials Advisor was being built as a SaaS offering, so they're unrestricted in model usage, but they're very cost sensitive, and so large models had these large token costs. And because these ingredient files are so big and require lots of context, we needed models that were capable enough that came with large context and multi-turn capabilities. So originally they built a system relying on a 400 billion parameter model, but they built an automated test harness. They implemented the prompts as config approach that we introduced. And what that led to was they could drop in a small language model from the Granite team and just test with that, because they don't have to update their agent deployment. They can just build a new config file and deploy that. And we found that actually cost reduced by 90%, and response times were reduced by a factor of 10 while improving agent accuracy. You have to think that models are only going to get better with time, and that doesn't necessarily mean that you have to keep updating your agent to keep in line with that. So as we were releasing newer and better models, we found that smaller models operated at lower costs, and for free they were able to get agent improvements as well. So how do you migrate to SLMs? I've sold SLMs to you, I've sold how to build our agents. What does it take to migrate? If you're already doing what we're speaking about in this talk, then nothing special, I guess. Go home and play around, just drop them in and see if they work. But in a little bit more of a actual pattern, context management is the name of the game when you're talking about small language models. You have to be a lot more intentional about the context and the instructions you're giving to the model. Be aware of not overloading multiple different logic gates within a prompt and multiple different tasks within a prompt. Think about splitting those multiple different tasks into different nodes and LLM invocations to get better accuracy. Also, whenever you swap in a different model, one prompt doesn't rule them all. This is even true for small language models. So do some prompt engineering cycle just to see if actually some prompt optimizations are able to get you better results with the SLMs that you're dropping in. And few short examples are my favorite thing. They're nothing hard, it's just here's an example, here's an example, here's an example of what I want you to do. Add them in. Doesn't matter if LLMs or SLMs, makes a big difference. Also, rely on your software engineering skills and use intelligent agent architectures. So think about combining and segmenting your tool sets into different domains and using the root and solve approach. Think about RAG as a powerful way of ensuring relevance and accuracy of your agent. And this last option of fine-tuning, it becomes an option. It's not something that I would recommend, and it's not something we often see the need for. But if you do have specialized use cases with a sufficiently small model, this does become an option. And you're seeing a lot of these little cute mushrooms coming up as well. Unfortunately, I'm not going to have a lot of time to do that, but I'm going to just flash this up. So we're building a programming model, a model for programming. No, a model of programming with small language models, and it's called Malaya. So the issue is not, can a small model do this? The issue is always, can a small model do this reliably on production data? So Malaya is this library that helps you do the task decomposition that we're talking about, making sure that you're not overloading one single prompt with multiple different tasks. It externalizes the control flow. So instead of saying in the prompt, hey, if the user has asked this, do this, otherwise do this, Malaya is going to help you externalize some of that control flow as code. Also, Malaya helps you with modularizing model capabilities. And basically the issue with any model is, how do you get the identification that what you wanted the model to do, it did? So Malaya has this instruct, validate, repair loop, which does the requirement validation and then reprompts the models with targeted instructions to update the model response if some requirements haven't been met. So I am being signaled that I don't have a lot of time, but there was a little notebook I wanted to show you guys. But if you guys are interested to catch me outside or over the 2 days, please do come across. I'd love to share some of that with you. There's also this repository, that we've been talking about and taking you through. If there are some topics and ideas and questions you guys have, please do go to Grand Agent Cookbooks. There's a discussion number 83 on there, and just start posting comments, and I'll get my team and I to start giving some feedback to you guys on those as well. All right, thank you everyone for listening.